Hello everyone, myself Sachin Gaware from RBNB College, Shrampur. In today's lecture, we continue our chapter from paper first, that is linear programming problem. In today's lecture, we solve the problem of minimization. We solve the problems of minimization by using graphical method. Now we consider a problem, minimize z equals to 7x plus y subject to, there are two constraints, 5x plus y is greater than or equals to 5 and next one is x plus y is greater than or equals to 3 and the non-negative constraint, that is x comma y is greater than or equals to 0. Now to solve this LPP, first we plot the graph, and to plot a graph we need to plot the lines, and to plot the lines we consider a table in which x equals to 0 and y equals to 0, here equation of line. We convert these constraints into a line. So the equation of first line is 5x plus y equals to 5 and next one is x plus y equals to 3. Now in this equation, first we put x equals to 0. When we put x equals to 0 here, we get y equals to 5. So we get the first point 0, 5. Similarly, if we put y equals to 0 here, we get 5x equals to 5, which gives x equals to 1. So for the first line, we get the 2 points 0, 5 and 1, 0. Now for the second line, if we put x equals to 0 here, we get y equals to 3, and if we put y equals to 0, we get x equals to 3. Now after getting these points for the lines, we draw a graph. Now since here a non-negative constraint is given, so we consider only first quadrant. Here this is the x-axis, this is y-axis, and here it is the origin. Now we take the appropriate scales, that is 1, 2, 3, 4, 5, and say here 1, 2, 3, 4, 5 and 6. Now for the first line, the 2 points are 0, 5, this is the 0, 5 point, and next point is 1, 0, this is the 1, 0. Now connecting these 2 points, we get the first line. By connecting or joining these 2 points, we get the first line. So this is the first line. This is the first line. Now for the next line, the points are 0, 3 and 3, 0. Here this is the point 0, 3 and this is the 3, 0. Again join these 2 lines. Again join these 2 lines. We get the, joining these 2 points, we get the second line. Now observe here both the constraints now. Now these both the constraints are of the type greater than or equals to 0. So we have to consider an region away from the origin, from the both lines, and so the required feasible region will be this one. This is the unbounded region. This is the unbounded region. So this is the feasible region. Now they give the names to the end vertices of feasible region. Say this is A, this is B, this is the C, this is x-axis, this is y-axis. So here we write, here the feasible region is, here feasible region is, check here, this feasible region is unbounded, it is not a compact, it is not a polygon. So it is the unbounded region. So here we write, here the feasible region is unbounded region, region A, B, C. This is the A, B, C, this is the unbounded region. Now, in which now write the known coordinates, that is the coordinates for A. Now this A is 0, 5 and this C is 3, 0. So here we write A 0, 5 and C 3, 0. Now observe here, this point B is the intersection of these two lines, first and second line. So here we write the point B is intersection of lines. Now the equation of lines are 5x plus y equals to 5 and the second equation is x plus y equals to 3. Now solving these two lines, now you can solve these two lines by any one of the known methods. Now here we take the subtraction of these two equations. So this can be written as 5x plus y equals to 5 and this is x plus y equals to 3. Now taking subtraction, it gives this plus y minus y gets cancelled. And here remaining 5x minus x, that is 4x equals to 2, which gives x equals to 1/2, Now putting this value of x equals to 1/2 in any one of these two equations. Suppose we put the x equals to 1/2 in this second equation, last equation. So by using this, we can write it as 1/2 plus y equals to 3, which implies that y equals to 3 minus 1/2. And so we get y equals to 5/2. We get y equals to 5/2. That is, we can say that we get the coordinates of B as 1/2 and 5/2. So here 1/2 and 5/2 are the coordinates. Now we get all the n vertices of the feasible region. So we consider now Z equals to. Now the value of Z is 7x plus y. In example, the value of Z is given as 7x plus y. Now finding the value of Z at each corner point of a feasible region, we start with from A. So here we write Z at A, that is Z at the coordinates of A are 0, 5. So it gives 7 into 0 plus 5, which gives 5. Now next one is Z at B, that is Z at, now the coordinates of B are 1/2 and 5/2. So Z at 1/2 and 5/2. So it gives 7 into 1/2 plus 5/2. So Z at B becomes 7/2 plus 5/2. This becomes 12/2. 12/2 means 6. So we get Z at B as a 6. And now lastly, Z at C. Now the coordinates of C are 3, 0. So Z at 3, 0. So it gives 7 into 3 plus 0 equals to 21. Now these all are the values of Z at each corner points of a feasible region. Now our objective function is we have to find the minimum value of Z. Now observe here, the minimum value of Z is 5, which is at a point A. And so we write the final solution, that is, therefore Z mean, that is the minimum value of Z equals to 5 at point A05. And here we complete the solution. Now consider the second example, that is minimize Z equals to 8x plus 10y. Subject to the constraints 2x plus y is greater than or equals to 7, 2x plus 3y is greater than or equals to 15, and y is greater than or equals to 2. And x comma y is greater than or equals to 0, which is the non-negative constraint. Now to solve this example, again we make a table in which we shows x equals to 0, y equals to 0. That is, we find the 2 points to plot a line or the constraint. Now the first line is 2x plus y equals to 7. Second line is 2x plus 3y equals to 15. And the third line is y equals to 2. Y equals to 2. Now here if we put x equals to 0, we get y equals to 7. So we get the first point 0, 7. Now if we put y equals to 0 here, we get 2x equals to 7. 2x equals to 7, which gives x equals to 7 by 2, or we can say 3.5. Similarly, here if we put x equals to 0, we get 3y equals to 15. 3y equals to 15, that is y equals to 5. And if we put y equals to 0, we get 2x equals to 15. And 2x equals to 15 gives 15 by 2. Now for the third line is y equals to 2, which is parallel to x-axis. So here we do not need to find the points. Now plotting these lines, again here the non-negative constant is given, x comma y is greater than or equals to 0. So we consider only the first quadrant. So now taking in first quadrant, taking the appropriate scales, six, 7, 8 and 9. Here 1, 2, 3, 4, 5, 6, 7 and 8. Now for the first line, the points are 0, 7. Here the point is 0, 7. And the second point is 7 by 2 and 0. Remember that 7 by 2 is nothing but 3.5. That is center point of 3 and 4. So now joining these 2 points, by joining these 2 points, we get the first line. This is the first line, passing through the points 0, 7 and 7 by 2, 0. Now similarly for the second line, the point are 0, 5. This is the 0, 5. And next point is 15 by 2, 0. Now 15 by 2 means 7.5. Here it is the 7.5, in between 7 and 8. So again, by connecting these 2 points, by connecting these 2 points, we get the second line. And last, the line is y equals to 2. That is a line passing through y equals to 2 and parallel to x-axis. This is the line y equals to 2. That is our third line. Now, if we consider here the constraints, all the three constraints are greater than or equals to. So we have to consider a region above the lines, or we can say that away from the origin of each of the three lines. So here the feasible region will be like this. This is the feasible region which satisfies all the constraints. Since all the constraints are of the type greater than or equals to 0, so this is the feasible region. Now, giving the names to the corner points of this feasible region, like this is the A, B and C. Now here the coordinates of A are 0, 7. The coordinates of B and C are unknown since they are the intersections of the lines. So now here we write, here the feasible region is, feasible region is unbounded region A, B, C, which is shown in the figure or graph, in which only the point A is known, that is A is equals to 0, 7. Now there are two unknown points. So we gave the names 1 and 2. Now number 1, the point B is intersection of. Now observe here, the point B is the intersection of first and second line. B is the intersection of first and second line, and the equations of first and second line are these. So intersection of the lines, first line is 2x plus y equals to 7, and the second line is 2x plus 3y equals to 15. Now solving. Now to solve, again we take the subtraction. So we can write here 2x plus 3y equals to 15 and 2x plus y equals to 7. Taking the subtraction. So this plus 2x minus 2x gets cancelled. So here it is 3y minus y, that is 2y. Equals to, now 15 minus 7 is 8. So we get 2y equals to 8, and which implies that, or which gives y equals to 4. Which gives y equals to 4. Now putting this y equals to 4 in any one of the equation. So here we put in first equation. So we get 2x plus 4 equals to 7. Which implies that 2x equals to 3, 7 minus 4 becomes 3, and therefore we get x equals to 3 by 2. So we get the coordinates of a point B as 3 by 2 and 7. So here the coordinates of point B is 3 by 2 and 4, not 7, sorry. Here it is 3 by 2 and 4. So we get the coordinates 3 by 2 and 4. Now number 2, the point C. The point C is intersection of lines. Now here, observe here, this point C is the intersection of second and third line. Second and third line. So the equations of second and third lines are here. So we can write it as the point C is the intersection of the lines 2x plus 3y equals to 15 and y equals to 2. and y equals to 2. Now solving this. Now to solving, put this y equals to 2 in first equation. So we get 2x plus 3 into 2 equals to 15. That is 2x plus 6 equals to 15. And which gives 2x equals to 9, and therefore x equals to 9 by 2, and therefore we get the coordinates of a point C are 9 by 2 and 2. 9 by 2 and this 2. So giving the coordinates, that is 9 by 2 and 2. Now take the value of z. Now z equals to. Now the value of z is 8x plus 10y. 8x plus 10y. Now finding the value of z at each corner points of a feasible region, starting with A. So z at A equals to. Now the coordinates of A are 0, 7. So 8 into 0 plus 10 into 7, which gives 70. Now z at B. Now the coordinates of a point B are 3 by 2 and 4. So 8 into 3 by 2 plus 10 into 4. So it gives, this becomes 4. So it gives 12 plus 40, that is 52. And lastly, z at C, that the coordinates of C are 9 by 2 and 2. So 8 into 9 by 2 and plus 10 into 2. Again this becomes 4. So it becomes 36 plus 20, that is 56. Now the objective function is to minimize the z. And observe here, the minimum value of z is 52. Minimum value of z is 52, which is at a point B, that is the point 3 by 2 and 4. So here we write, therefore z mean equals to 52 at point B, and the coordinates of B are 3 by 2 and 4. The coordinates of B are 3 by 2 and 4. Here we complete the example. Thank you.